University Federal Credit Union. I'm super excited to be joining you this morning. I am an MSU alumni, so go green. Thank you. Sometimes people don't always do that. Then you know which crowd you're in. Anyway, I am excited to be here on behalf of the credit union this morning. We love to be able to participate in events like this. We did start right here on campus in 1937 out of a desk drawer, and we operated that way for about 20 years. We moved into our first headquarters, our second headquarters, and now we operate out of 2 headquarters here in East Lansing. We serve over 280,000 members now, and we have $4.6 billion in assets. And those memberships and that ability to serve our community is really what drives us every day, so we can participate in wonderful events like this. So I'm so excited to be here to represent that, but also to share with you that mission of being able to support our community, support the Spartan community, and really reinvest that membership back into such wonderful programs and events. We really do like to focus on educational opportunities. We really work with our members to make sure they understand how to have their best financial future possible, and it's because of events like this that we get to talk to such wonderful groups and support that same education on a higher level. So thank you so much for allowing me to come and chat with you today. If you do have any questions about the credit union and our service packages, please let us know. We do offer a full range of products and services, and I will definitely be here, so I'll be in the back corner if you have any questions at the end. But I just wanted to say good morning, welcome you to the event, and have a wonderful day.
Good morning. Good morning. Our speaker today is Dr. Lois Wolfson, a senior specialist with the MSU Department of Fisheries and Wildlife and Institute of Water Research. She serves as MSU Extension's representative in the North Central Region Water Network. She has been on the faculty at MSU since 1997 and started her career at MSU several years prior to that. Her work involves educational program development, outreach and engagement in lake ecology, and emerging water issues, including PFAS, which we're here today to discuss, invasive species, and harmful algae blooms. Her current research is focusing on utilizing floating wetlands to reduce nutrients from tile drain. She received her MS in botany and PhD in fisheries and wildlife, both from Michigan State University, and in 2018 was the recipient of the MSU Distinguished Academic Specialist. We welcome Dr. Wolfson.
All right. Well, thank you very much. It's a pleasure to be here, and I'd like to thank Elizabeth and Liz for inviting me here. I think I'm echoing a little bit. So, as you heard, I too am an alumnus of Michigan State University, and I'm very pleased to see this huge crowd here today. It's very nice to see people in the front row. Sometimes when I'm teaching with students, they're all sitting in the back row. So it's really nice that I saw people come up to the front, not just because those were the remaining seats. So I'm here today to talk about an emerging contaminant that has been in the news quite extensively, maybe for the last couple of years, but it's been around since about the 1940s. And of course, you know what I'm talking about, it's PFAS. And it has been used in multitude of products that we use as consumers within industry, and it's unfortunately gotten into our groundwater, our surface water, in fish and wildlife, and also in our bodies. So today what I'm going to do is talk about PFAS, talk about where it comes from, what it is, some of the health-related issues relating to PFAS, what we know about it, and then some of the work that's going on both at MSU with research and also within the state. Okay, so PFAS chemicals, they're man-made. They're synthetic organic compounds, and the name for PFAS as a whole is per and polyfluoroalkyl substances. All right, and there's not just like 1 or 2 or 5 or 10 or even 500. There's thousands of them. And in fact, there's a chemical registry which has listed about 4,700 plus of these PFAS chemicals. And now, don't think that I'm going to have this be really technical and show lots of structural formulas and stuff. But I want to show this one right here. There's 2 PFAS chemicals that have been used much more extensively than other chemicals, and they've been around the longest. And those 2 are perfluoroalkyl sulfonic acid, or without the hydrogens, sulfonate, and that's known as PFAS. So the whole suite of chemicals are PFAS. This is PFAS. And then also perfluorooctanoic acid, which is PFOA, and most people refer to it as PFOA. Now, one of the properties of it, and why I'm showing you the formula, is that it's a chain of carbons, and attached to the carbons are fluorine atoms. All right? And that bond between fluorine and carbon is the 4th strongest bond in nature. And for organics, it's the strongest bond in nature. Very, very difficult to break down. Now, what's also important about this is that if you see there's 8 carbons here, these are considered to be long chain carbons. Now, these have been retired. Both PFAS and PFOA have been retired. They're not used anymore in the US, but they have been replaced by what are called replacement chemicals. And one of them is called Gen X. So there's still these PFASs in the environment and in the industry, but it's not these particular 2 anymore. But what I'd like to do as we go along is tell you some of the differences between these long chains and these new replacement chemicals, the short chains. So these properties vary greatly, so you can't just say if it occurs for PFAS, it's going to be true for all other chemicals. So what do we know? As I just mentioned, they've been in our environment since the 1940s. They've been used in all types of industries across the world. And they're persistent in the environment. Those strong bonds, they don't break down in nature. And you've probably heard them called the forever chemicals. And that's what they are, because once they're in the environment, by nature, they're not going to break down. And they're also in our human body, and I'll talk a little bit about that in terms of the half-life and how it may or may not be excreted from the body. Now, I'm sure all of you are familiar with some of our legacy organic compounds like PCBs and dioxins. Those, when they get into the human body, they attach to the fats. PFAS chemicals attach to proteins. They bind to proteins and to the albumin in the serum or the blood. And so there's much more functionality going on with proteins than there are with fats. And also, if you're filleting like a fish, for example, or trimming meat, you can trim the fat off the meat and remove some of that organic chemical. You can't do that if it's in the meat or in the protein of animals or fish. Another characteristic of it is that there's limited excretion by the kidneys. So normally the kidneys are going to cleanse the blood and then excrete those toxic products or any other products in the urine. But with PFAS, what happens is the renal tubules reabsorb that PFAS and then put it back into the blood. So it stays in the body for quite some time. This is different than animals, which are able to excrete the PFAS fairly readily. They also can bioaccumulate over time. So when they get in the body, it more starts to accumulate than to actually leave the body, either through excretion or being catabolized down. And they also easily move through the environment. So even though they may not be produced in a particular area, they're being found in Scandinavia, for example, where they're not even being produced. They have been found in the oceans, which is probably the final place where they're going to be be found over many centuries. They've been found in the Antarctic, in freshwater lakes in the sediments. They've been found in the Arctic, and even there was one study that showed polar bears had PFAS in their blood. So they're very mobile, they're water soluble, and they move both within the soil and in the water. Even though you're not, we're saving questions to the end. If you have some burning question to ask as I'm going along, feel free to ask it, and I'll try to remember to repeat it and then help answer the question. They have some great properties that have made them very useful for these variety of products that they're used in. And one is that they repel grease and water and oil, and they have products that make them stain resistant as well. And they resist thermal and chemical degradation, and that's why they're not only not being broken down, but they stay in the environment because these processes that are going on in nature aren't strong enough to break them down. There is some evidence that that PFAS chemicals lead to adverse human health effects, and I'll talk about that a little later. But in 2004, there was a settlement suit that was done with DuPont Chemicals, and part of that settlement was a massive study of about 70,000 people within the community that was contaminated to look at PFAS exposure and the effects on humans. So a lot of that study results, it was with a group called the C8 group because of carbon 8s. And a lot of that information about human health effects comes from that study. Now, the half-life for these two are this is for PFAS and PFOA, about 3.8 years for PFOA, up to about 5.4 years for PFAS. You'll see some differences. Sometimes you'll see in the literature going out to maybe 8 or 8.5 years for the half-life, meaning that how long it takes for half of that chemical to be removed from the body. All right, long years, much less in animals. In animals, monkeys, about 120 days. With rats or mice, anywhere from 27 to 38 days. So a huge difference. And then also, there's a big difference between the long chains and the short chains. So while the long chains have huge half-lives, not huge, but in years, the short carbon chemicals, or the short chain chemicals, have half-lives also in days and months. So huge difference there. Same with the bioaccumulation for the short chains, much less than the long chains. The long chains, though, are thought to be more toxic than the short chains and more persistent. But you see, I have a question mark there, because there have been some more recent studies that show that the short chains are just as persistent as the long chains. So throughout what I talk about, I'll say, well, more studies are needed. And certainly there are more studies needed on a variety of issues relating to PFAS. So these are some of the more recent literature that's talking about short chains PFAS. There's not as much literature on the short chains compared to the long chains, but some of the factors you can read here: more mobile, able to leach more in groundwater, more as persistent as the long chains, and that's different than what some of the older literature says. Less bioaccumulation, as I mentioned, and one newer study by Scher et al. In 2018 looked at PFAS in plants, and there's not a lot of studies in terms of, do plants uptake it? When they uptake it, where does it end up in the plant? But this actually showed that with short chain PFASs, the plants can uptake those chemicals and bioaccumulate them in the edible parts of the plant. And of course, again, more research is needed in that particular area. Two other factors is that there are what are called precursors to PFAS chemicals. And these precursors can be generated into PFAS and PFOA. So they can be generated during wastewater treatment. For example, if ozonation is occurring in the wastewater treatment, some of those precursors can actually change or be transformed into PFAS or PFOA. And also some soil microorganisms can also change it. So what's coming into a wastewater treatment plant, whatever PFAS chemicals are coming in, there might be even more going out than what's coming in after the treatment occurs. All right, as I mentioned, PFAS has been used in a variety of industries since the 40s and the 50s. In 2002, 3M, which makes Scotchgard, voluntarily reduced the amount of PFAS it was using and slowly phased it out, and it was completely phased out in 2012 from use in the US. In 2006, the EPA asked the 8 major companies and industries that were using PFOA and PFAS to slowly decrease emissions and decrease the use of these chemicals by 95% by 2010. They complied with that, and by 2015, PFOA was no longer being used. And in fact, I was watching one of those advertisements on ceramic nonstick cookware, and at the bottom it said, no PFOA. So there's no PFOA or PFAS in these products now, at least in the United States. They may still be generated in foreign countries. And although there hasn't been evidence of products being imported that have PFAS and PFOA in them, they could come into the consumer streamline. So some of these industries, PFASs, excuse me, are very good at protective coatings. So they've been used in a variety of products, semiconductors, wires, electronics. They've been used in metal plating industry, in tanneries and textiles, particularly for their stain-proof and waterproof abilities. Another area that they've been used is with aqueous film-forming foams, which is shortened to AFFF, and most people call it aqueous firefighting foams, right? But these have been used extensively since the 1970s on military bases, Air Force bases, in airports to put out fires. Again, the properties of PFAS make it very, very good for putting out fires because they can stand those high heats. They've also been used in multitude of consumer products that we use all the time, stain-resistant carpeting, nonstick cookware, clothing that's waterproof, cosmetics, and then also in fast food wrappers. So again, to keep those oils and greases in the paper as opposed to leaking out in the box, they were used in wrapping fast food, in the internal part of the bag of microwave popcorn, and in pizza boxes as well. And other products like shampoos, dental floss, waxes, polishes, a great variety of products, which is a little scary. So this, so this map was produced using federal drinking water data by what's called the Environmental Water Group. It's a watchdog group, along with Northeastern University in Boston. And just by your reaction, when you look at it, it looks like, wow, Michigan's really in trouble here. They have a lot more PFAS contamination than most other states in the US, and probably all other states. But it's a really misleading map. And this has gotten around quite a bit. And so people think that Michigan is just overwhelmed overwhelmingly contaminated with PFAS. But the gist is that Michigan and the state of Michigan has been very proactive and vigilant in looking at places around the state, from industries where they were using the AFFF, and looking at the drinking water and in animals to actually find where PFAS is across the state. So it's a misleading map. There are a lot of places in Michigan that are contaminated, but it's not to say that these other areas are not. It's just that we're sort of taking a lead in looking for PFAS in the state. So how do we become exposed to PFAS? And from the consumer products, you have an idea, but mostly it's from drinking contaminated water. So that could be from well water, it could be from municipal supplies, from non-community supplies. And then also by eating either the parts of the plants or by fish and wildlife that may have been contaminated by PFAS. There's a variety of other pathways. It's in the dust, so if you actually consume it or intake it with dust particles, that could be one pathway. Eating some of those foods that were packaged with PFAS chemicals is another way. And let me just talk about those two. Very small trace amounts if that occurs. So compared to drinking contaminated water, much higher way to get PFAS in your system than these other ways. There have been a couple of studies that have looked at in utero fetal exposure, and some of them have shown that yes, the PFAS has passed through the placenta, but they're not seeing huge effects on the fetus after looking at if it's been exposed. And in fact, there's some hormone levels that they've looked at associated with ovary development compared to PFAS, and looked at a group of young ladies in the population and didn't see decreases or changes in the hormones based on PFAS exposure. And then also PFAS can get into the breast milk of women, and so is that a concern? It could be, but according to the American Academy of Pediatrics, they indicate that the benefits from breastfeeding outweigh the possible problems associated with exposure to PFAS, particularly in the levels that have been being found. And then one more part about PFAS, touching it or getting it on your hands if it's in water or in carpeting or some product is not a prime way for PFAS to get into people. They have seen levels as high as 400 parts per trillion, and people are not, it's just not easily absorbed through the skin that way. All right, so if drinking water is one of the ways that PFAS gets into our systems or into animals or into plants, it might be important to know something about groundwater. So about 43% of the people in Michigan get their drinking water from groundwater. There's about 650 community public supply wells, over 10,000 non-community supplies. So those are supplies that serve schools and mobile parks, hospitals, et cetera. And then there's over 1 million private wells. So oftentimes a person might think that if a neighbor has had their water tested, or if a school has had its water tested, and no PFAS was found or no contaminant was found, then there's not going to be a contaminant in their water supply either. And that's not necessarily true, because it depends on where the wells are in the aquifer and also the soil types. So The Michigan Department of Health and Human Services put together a short little video explaining this and looking at plumes of PFAS and how it could get into well water. And I thought it'd be interesting to show that to you. It's only a 2-minute video, so we'll try this. I'll move over here.
Sources of PFAS could include unregulated dump sites, landfills, firefighting foams, and factory waste. PFAS can seep through the ground and eventually mix in and flow along with the groundwater, the water that can be found underground. The PFAS that is in groundwater. Sources of PFAS could include unregulated dump sites, landfills, firefighting foams, and factory waste. PFAS can seep through the ground and eventually mix in and flow along with the groundwater, the water that can be found underground. The PFAS that is in groundwater is called a plume. The amount of PFAS at any given point in a plume can vary as the groundwater moves along. Here we see the red section of the plume showing higher amounts of PFAS and the purple section showing lower amounts. This is one reason for potential differences between test results. The plume will move over time. As the plume reaches these wells, the amount of PFAS found in the water could change. Another reason is well depth. Here, the first well is shallower than the others and is drawing water that has the highest amount of PFAS. The second well is deeper and is drawing water with lower amounts of PFAS. The third well is the deepest and is not within the plume. No PFAS is found in that well. In addition to depth of the well, the type and structure of soil and rock around your well can alter how a PFAS plume can get to your well. PFAS can move easily through sand or gravel. However, soils with a lot of clay in them or some types of bedrock can prevent PFAS from getting to your well, or at least slow it down. How your well was constructed and how much water you use can also make a difference. This is a simple example of a plume. Plumes often have different shapes and move at different speeds. Some wells may be closer to the plume than others. Wells that draw water from the center of the plume area could have higher amounts of PFAS in their water. Lastly, consider the household products you use that might contain PFAS. These products have been used to waterproof, stain-proof, and create nonstick surfaces. They're used in most households. Products include many laundry products, carpets and upholstery treatments and sprays, waterproof clothing, and some cosmetics. Wastewater containing PFAS, such as carpet cleaning wastewater, can go down your drains and out into your septic field, and may result in low levels of PFAS in well water.
It could be for any contaminant. So let's talk a little bit about some of the health effects. There have been a lot more studies done on lab animals than there have been on people. But if we remember what I was talking about with respect to the excretion rate, animals excrete PFAS much faster than humans do. So there has to be more studies done that can link what the exposure is to PFAS and the health effects for humans. But with some of the animals that the studies have been done, they have found that there's been changes in functioning in some of the organs, particularly in the liver, in the thyroid, and the pancreas. They have seen some developmental effects. So not only decreased fertility, but low birth rates in these animals. One common thing among humans and animals is an increase in cholesterol. And then finally, there's an increased risk of cancers and tumors have been found, again, in the liver and the pancreas and also the testes of some of the animals. Doesn't mean necessarily that it will cause cancer in people. And although PFOA has been listed as a carcinogen, PFAS has not been. So again, with humans, we can't directly say if it occurs in animals, it's going to occur in humans. But the studies based on that one large study, and then the CDC has done other studies, and I'll show you a graph in a minute, and looking at some potential health effects from humans Also, people that have been exposed to PFAS who have worked in industries that use the chemical, they have been studied in terms of taking blood samples, taking urine samples, and looking at effects and doing some analysis with that. So developmental problems for infants and older children, it's thought that there might be behavioral changes, learning issues with this, or growth problems. Lowering a chance for a woman to get pregnant, interfering with the natural hormones in the body, and also with the immune system. And then again, with the increased cholesterol levels, that's been the one factor that has been seen pretty much across the board, that there's an increase with cholesterol in people that have been exposed to high levels of PFAS. And then perhaps an increased risk to cancer. So the CDC have done some huge studies. They do them on a regular basis, looking at the blood serum and the urine of people across the U.S., all different age levels. And what they have found is that they were looking for, I think it was 7 different PFAS chemicals. And they found 4 of the more common ones. I haven't mentioned these other 2, but these are 4 of the more common ones in the serum of nearly all people tested. And it's been said that anywhere from 95 to 99% of the people in the U.S. have at least some trace amount, if not more, PFAS in their blood. So this was one of the studies that they did. And again, from these 4 chemicals, what they were showing is from 2000 to 2014, a pretty substantial decrease in both PFAS and PFOA, and then not as much in the other 2, but they're lower to start with as well. So for blood PFAS levels, decreased by 80%, and PFOA by 60%. Now, of course, both these chemicals have been are no longer made. They are retired essentially. But it is encouraging that these levels in the blood serum have decreased. So the EPA has come up with a lifetime health advisory for both PFAS and PFOA. And they've made that advisory at 70 parts per trillion of either PFAS or PFOA alone or together. And a lifetime health advisory means that you could be exposed over the course of your lifetime to this amount on a daily basis and not suffer any ill effects, any adverse health effects from being exposed to PFAS at this level. So you might say, well, a part per trillion, is that a lot? Is that a little? If you think about it's 1 part in 1 trillion parts, so 1 drop in, if you took 20 Olympic-sized pools and put them together, put 1 drop of a liquid in there, that would be a part per trillion. If you took 1 second in a trillion seconds, but that doesn't mean too much, but if you changed it into years, it'd be 1 second in almost 32,000 years. So it's really a small amount we're talking about, even though it's 70, but people say, well, is that significant? Anytime there's a chemical that bioaccumulates, is toxic, and you have long-term exposure to it, then yes, that can be very significant. And there are several states, including Michigan, that think that 70 parts per trillion is too high, and that level should be lower. And so some states have gone beyond looking at a lifetime health advisory and have established maximum contaminant levels. The lifetime health advisory is not enforceable and it's not regulated. It's just a guideline. But MCLs, maximum contaminant levels, are enforceable. And so New Jersey and Vermont have lowered their standards for both PFAS and PFOA. Vermont for 5 different chemicals. Michigan's working on it right now. So they're in the process of developing draft rules to develop MCLs for 7 different PFAS chemicals. And the EPA knows that Michigan's working on this. But for now, the current standards for Michigan for surface water, it's 11 or 12 parts per trillion for PFAS, and that's because of bioaccumulation in fish. For groundwater cleanup, and one of the first states to look at the cleanup of groundwater, 70 parts per trillion. And then for our drinking water, they're still using the lifetime health advisory that EPA has set of 70 parts per trillion. There are ways to treat PFAS. The 2 main ways, if you're looking at home treatment, is through granular activated carbon and also through reverse osmosis. There are 2 nonprofit organizations. One is called NSF International. It used to be the National Sanitation Foundation. It's located in Ann Arbor. And another, the American National Standards Institute. They come up with standards that filters must pass in order to be certified to be able to remove PFAS chemicals using either GAC or reverse osmosis. And so there's 2 standards right now, standard 53 and one's 58, one's for PFOA and one's for PFAS. So if you're looking for filters, they should have that certification on them if they meet those standards. And PFAS, it's not a good idea to boil it because it will just concentrate it. So I want to talk just a little bit about what the state is doing and then what Michigan State is doing with respect to PFAS. So by executive order, there was a team established called the Michigan PFAS Action Response Team, and it involves 7 of the state organizations, including the DNR, EGLE, Michigan Department of Public Health, Department of Health and Human Services, Transportation, Military and Veterans Affairs, and Licensing and Regulatory, and MDARD, Michigan Department of Agricultural and Rural Development. So, and then there's also scientific committees and citizen group committees that have been formed as well. As I said, Michigan has been very proactive in looking at drinking water sites, or not sites, but groundwater sites where drinking water is used, lakes, fish, wildlife, and they have a website which is very interactive. You can get on their site and click on a map of a particular location and get all kinds of information on what has been occurring almost on a daily, weekly, or monthly basis. So it's very in-depth. When I just went on it, when I was putting together this presentation, I just saw a couple of things relating to fish and deer, and you can read them right here what it says. But it gives you up-to-date information on where they are with respect to finding different PFAS chemicals. So one thing that they look at quite extensively is fish consumption advisories. So the Michigan Department of Health and Human Services puts out an Eat Safe Fish Guide, and on the MPART website, they list those areas where PFAS or PFOA or one of the other PFAS chemicals is a concern. So again, I just pulled off a little part of the chart. This is for the northeast part of the state, and it doesn't even list all of them here, just what I could fit on the screen. But these are hyperlinked actually to the full fish consumption guide. And what they do is they list the county, they list the water body, the types of fish, what size of fish you can eat, and then what the chemical of concern is. And there you can see for the northeast part, this is around the Osable River, Clark's Marsh, the Wurtsmith Air Force Base. There's a lot of do not eat advisories right now for fish consumption, do not eat advisories. So it's a good idea if you are fishing to go out and make sure that you look at the Eat Safe Fish Guide before you bring your fish back and fillet them and eat them. Another concern is foam on lakes. And PFAS can produce foams on lakes. But overall, foams are natural. So when it can come from, well, people dumping or moving, like, say, detergents or whatever into the lake, or organic material or organic carbon. But generally, when plants die and decompose, the breakdown products, the oils and such in the plant, start causing these foams, and they're like surfactants in the water, and they mix with the water, mix with the atmosphere, and cause these natural foams occurring along the shoreline of lakes. Usually it occurs in a more enriched lake than in a very pristine lake. But there are differences between those natural foams and what we see, foams that have been formed by maybe the use of the AFFF. And so these, I pulled these off, again, the MPART website, showing the differences, the colors being more of a brownish white with the natural foams, because as they come into shore, they slowly start browning because they're picking up a lot of the sediment and the substrate, compared to the PFAS foams being much whiter. And then also the PFAS foams are usually stickier feeling as well. Now, I have here non-confirmed because this is a picture I took out at a local lake, and I suspect it is not PFAS, but I didn't send it in to be tested. And the same with this one. It's whiter, and it looks like it certainly could be PFAS, but it hasn't been confirmed. So Michigan, again, the types of PFAS that they're currently assessing is a whole list, and this is another one of, you can see all the different names here. Some of these are the precursor chemicals. Some are the short chains, like this one right here is that Generation X, or that Gen X chemical that I was talking about, and some are the long chains. So they have a mix of chemicals that they're regularly testing for when they take samples from either groundwater or surface water, or for the fish that they're testing as well. The ones with the symbol indicate that they're testing for those chemicals as well. And the EPA just came out with a new testing procedure for these different PFAS chemicals, which increased the number of PFAS chemicals that you could look at and follow their guidelines. Okay, so MSU, what's going on at MSU? So these are just some sample research projects that either I know about or I've read about. There's certainly other ones going on that I haven't heard about, but these are just a sampling. So Dr. Carignan in Food Science and Human Nutrition, she's been on a national panel, a PFAS panel, for several years, and she just received an EPA grant working with North Carolina, Duke University, and Colorado. And they're looking at communities in each of those states that have been exposed to PFAS chemicals. And so they're looking at the exposure and the effects of that chemical on the people, and how much is in their blood and within these communities. Dr. Murphy is in the Department of Fisheries and Wildlife, and she's looking right now at how PFAS bioaccumulates in bluegills, and she's creating this model, and it's called a TD model, and what it does is simulate the amount of toxic material or what's ingested into the bluegill or into a fish, and then what occurs over time, some type of time series looking at how much that fish is being affected by that toxin. And I probably didn't give it a good explanation compared to what she's really doing, but that's some model that she's using, because there's models need to be used to find out what's happening with PFAS, because we can't look at every different type of PFAS and every different type of animal and try to figure out what's occurring throughout the environment. And then she's also trying to model the transport of PFAS through the Huron River. The Huron River also has a do not eat fish consumption advisory from Oakland County near Wixom all the way to where it empties out into Lake Erie in Wayne County. And then multiple professors and 7 departments have been involved in developing a white paper on PFAS. And you can see the various issues that they're looking at in terms of fate and transport and toxicity and also risk assessment. And this paper is coming out soon, but what it does is say these are areas that we don't know enough about and where more research is needed. Dr. Fawn is a professor in engineering, and this one I'm not familiar with. It's some type of what's called biochar technology. All I know is biochar takes organic or biomass and converts it into charcoal, but he's looking at these shorter chain PFASs and trying to see how easily or how difficult it is to break them down. And then there's a center on campus. It's nationwide. It's called the Fraunhofer Center for Coatings and Diamond Technologies. And in the lab, they've been able to break down some of these bonds with their electrochemical oxidation using what are called these boron-doped diamond electrodes. But they're trying to scale up so that this could be used at a wastewater treatment plant, for example. And then Dr. David Heineman in Earth and Environmental Sciences is a hydrologist. He's consulting with Eagle, the former DEQ, focusing on movement. He focuses on the movement of contaminants in groundwater. He's not specifically looking at PFAS, but his background and knowledge of contaminant movement in groundwater has been very useful. And then with MSU Extension, I'm part of Extension, and we've been trying to get out more information to the public about PFAS and also to our county extension educators in all the counties of Michigan. We've established a helpline called Submit a Question, or similar to an Ask the Expert. And this uses if you're familiar with the Little E Big X Extension national platform. So people can submit a question to us, and we will try to get back to them within a very short time frame, either being able to answer the question. In most cases, there's questions that we can't answer, and we either refer them to a researcher or provide more information to them. And then there's also some other activities going on in Extension. For example, Dr. Cheryl and his associate, Ms. Stringa, are working on an online curriculum it's really mainly for health and nutrition, but they're having a piece of that online curriculum be devoted to PFAS. So we've all heard in the news about all types of contamination occurring on Air Force bases and groundwater. These are some of the bigger ones that we've heard about at Worth Smith Air Force Base, decommissioned many years ago, but through their use of AFFF, that firefighting foam, some of the groundwater has been contaminated. There's fish consumption advisories in this nearby Van Etten Lake. Some of the other communities have been affected as well. Samples have been taken by Eagle and some of the other groups, and they have found about 28% of the samples are above that lifetime health advisory for PFAS and PFOA. The Wolverine Tannery on the other side of the state in Kent County, also no longer in use. I think they stopped using that tannery back in 2009, but they disposed of a lot of their sludge and sewage in landfills and in gravel pits, and also they spread some on the land as well. And so now that material has leached down to the groundwater, and there have been areas that have been over 5,000 times the lifetime health advisory for PFAS and PFOA in those areas. And then in Parchment, that was in the news a little while ago, where they think it was related to a paper mill factory. And again, groundwater contamination occurred. They have since moved to the drinking water supply for Kalamazoo, and so they were delisted as an area of concern in 2018. But there's a lot of other places besides those three that maybe we haven't heard as much about. This also comes from the MPART website. So they give you a map, and again, I told you can hyperlink. These are all hyperlinked to much more detailed information. But if you gaze down the list here, what you'll see is the places where they're prioritizing their work and looking at Air Force bases, commercial airports, industries that were using PFAS, and military bases as well. So I'd just like to end with, there's a lot we don't know about PFAS, and I've just covered really a surface look at PFAS chemicals. These are some of the research needs that were put in the white paper and also from other papers that I've explored in terms of where the research is needed. For PFAS exposure, how much is safe for humans in terms of the differences in toxicities between these PFAS chemicals. Bioaccumulation studies, the travel time through groundwaters and soils. We know it's mobile, but how's it moving through the groundwater? And then with all our consumers products, even though most of them now are these short chain PFAS chemicals, how fast are they leaching out of those products and getting into humans? And there's so many other aspects that I didn't want to keep listing them, but it's just an area of concern that I think requires more research, both on animals and peoples, to get a better picture of this widespread problem in Michigan and throughout the US and the world. So that is what I have, and I thank you for your attention, and I think we're going to open it up for questions.
Yes, we're open to questions. We would ask the speaker please to repeat the question.
Yeah.
So, questions? Yes.
I don't know if they still sell children's, particularly pajama wear with fire retardant. Is that one of these chemicals too?
Repeat the question.
Yes. So she wants to know if the children's pajamas that are sold have fire retardant in them, and is the chemical within that? I don't believe it is. I'm not absolutely sure, but I don't think PFAS has been used as the fire retardant within the clothing, although it has been extensively used in the textile industry, more for waterproof clothing than any type of fire retardant.
Question here?
Are refrigerator filters effective for removing PFAS or any other chemicals?
He wants to know if refrigerator filters are effective for moving PFAS chemicals. Can you be more specific on what type of?
Cylinders you put in every so many months.
Oh,
on the bottom for drinking water
Oh.
from the refrigerator.
Yeah, oh, I see. Oh, yeah. You mean like a Colligan or I shouldn't mention a brand name, but some type of filter like that. Some of them use some type of granulated activated carbon, and if they do, then yes, they would be effective. If they're using something like, if it's a distillation or some type of ion exchange, and many of those filters use ion exchange, then no, those are not as effective at removing those PFAS chemicals. So it really depends what the filter is.
Christian?
Is there any theory about why the animal body removes PFAS faster than the human body?
As I mentioned before, the question is there any reason why animals remove the PFAS faster from their bodies than compared to humans? And it has to do with the renal function of the kidneys. And just that within animals, it's that those renal tubules do not reabsorb the PFAS faster or as much in animals, so they are able to excrete it. But I really have not seen any reason besides that indicates why they remove it faster. But good question.
Question?
And you talked about microwave popcorn on the inside of the bags.
Mhm.
That came to light many years ago. Has that been taken care of now?
Well, they're still using
Repeat
some
the
of.
question?
Yeah, sorry. Do you want to repeat it? So she said the issue with microwave popcorn bags, that issue came up several years ago, and is that still an issue? So in a sense, yes, they're not using the same chemicals for the keeping that grease or those oils in the bag. So they're different chemicals, but as I mentioned here, some are they're shorter chain chemicals and they don't have that toxic effect that the older chemicals did, but there are some still issues relating to persistence. And so if it's getting in your body, even in trace amounts, and usually from those packagings, they are very trace amounts getting in, but over time, if they're bioaccumulating, then that could be an issue.
Question?
In this area, how much water contamination is PFAS, Lansing, East Lansing?
On the MPART website, there is.
Repeat the question.
So the question was, in the Lansing area, how contaminated is our groundwater? Thank you. I probably, every time you'll have to remember to tell me that. So in the Lansing area, there is an automotive place that has been on the list that has,
Plating.
what's that?
Adams Plating? It was on the list.
Well, okay. So I'm not mentioning names here, but yeah. So there was that one, and then there's one other that has been listed. But so far there's not at least in the East Lansing area, a lot of industries that would have been using PFAS. And so those areas, just because it hasn't been tested a particular area, it doesn't mean it's not there, but likely not unless it's moved from some other area in the groundwater.
Yes.
When I send my well water into the county to be tested, do they routinely test for PFAS?
So the question is, thank you. When he sends his water into a place, a laboratory, do they routinely test for PFAS? And the answer is no, they do not. PFAS is it's very expensive to test, and of course, even there's so many chemicals you could test for. But even that suite that the Eagle is testing right now, it probably costs about $500 a sample to test. There's only a few labs in the country that have the ability to test at that particular level in the parts per trillion. And so it is not one of the common tests. However, if you suspect PFAS contamination in your well, you should contact your county health department and talk with them about it. And if it's deemed that the area is contaminated, then Eagle would be contacted and come out and take a sample. But generally speaking, if you just have a well and you're in the city, or not in the city, but out in the country, chances are that they're not testing for it, and probably the PFAS isn't in your well water.
Questions? Let's see. Back row here.
Are the I don't even know what they're called, that people have on their faucets
Yeah.
that purifies supposedly the water, is that effective?
So the question is, are the point of use devices, that's what they're called, that are on faucets, are they effective in removing PFAS? So there's a bunch of different filters that can be used, and I mentioned the reverse osmosis and the granulated activated carbon. If those two are being used and the right filters are being used, then yes, they are effective in removing it. But distillation, for example, that will not remove it. And you can look at the companies, and they should tell you what filters are effective at removing what chemicals. So some filters are good at removing lead and other heavy metals. Some are good at removing organics. So you have to look at these different filters and find out. And that's why there's this certification for these filters. And if you go to the store and you buy a filter, look to see if that ANSI 53 or 58 is there for actually being certified to remove PFAS.
Yes.
I have a cottage in Lake Huron, and we have now and again very white foam that we assumed was somebody floating their washing machine. And most of us have very shallow wells. Do we need to be worried?
So are you near the Worth-Smith Air Force Base?
Yeah.
So the question was, they live up in along Lake Huron, and they have seen white foam. They thought it was from some type of detergent getting into the water, but now they want to know if they should be worried. So now I'm asking, are you up near that area? Because that area, there's several places within that area that have seen this white foam like in Van Etten Lake, for example, and they have discovered that yes, there was PFAS contamination in it. So it depends where you are in the state, even along Lake Huron. But what you might do is check on the MPART website and look at the areas that have been affected and see if that's a problem. Now, what you can also do is just sort of look at it and see if it is white. You could put on some gloves, even though PFAS doesn't really absorb through the skin. I'd still suggest maybe wearing some latex gloves and just sort of touching it and seeing if it has that sticky feel or not. And generally, the stickier feel is evidence that it may be PFAS.
Question?
Yes. We have access to several lakes in Shiawassee County. Is there a way to have those lakes tested for PFAS? We send the water in for E. coli and all those things. Is PFAS part of the routine?
No. So in Shiawassee County, and they send in, is it from lake water or drinking water? Lake water. PFAS, as I mentioned, very expensive to test for. It's not one of the common ones. Eagle has gone to specific places where there might be manufacturing industries that are using PFAS and have looked at surface water, and particularly with fish in surface water, mainly groundwater though they've been testing, but it's not something, if you sent it in, you would have to, first of all, you'd have to get the right lab to do it. I believe in Michigan, Merit Lab is certified to do the testing. Of course, there's a drinking water health department in part of Eagle, but if you're sending in surface water samples, make sure that you tell them it's a surface water sample and not a drinking water sample. But they would not do PFAS on a routine basis.
Is it used in agriculture a lot? Because we're really in an agricultural area.
She's talking Shiawassee County, is that
Yeah,
right?
in Shiawassee County. She
Could
wanted to
repeat a
know.
little bit, yeah.
Yeah, and is it used, is PFAS chemicals used in agricultural settings? If there's biosolids from wastewater and that's being applied to ground, then the biosolids may have PFAS in them. But generally, and again, if they're using irrigation water from groundwater and that groundwater is contaminated, then yes, but generally, no, the PFAS would not be used in the agricultural setting.
In the back row?
Sometimes when it rains real hard, the downspout, the water coming through my downspout will have that foam at the bottom. Is that from the rain or is it something that's in the ground?
So when it rains,
Repeat the
that's what I'm
question. Yeah,
saying.
okay.
When it rains, there's a downspout where the water comes through, and sometimes there might be a foam in it. Is that PFAS? Probably not. That's similar to what's happening in lakes. There's leaf materials up on the roof and other bird stuff, just other organic material mixing with the atmosphere, mixing with the water, and getting down and coming out through the pipe. And it's probably just a natural process.
Questions? Anyone? Everyone?
Everyone's asked lots of good questions.
Okay, there's one.
Well, I always like to know your trajectory. So how did you get from botany to
Yeah, right,
Wasn't it
right.
botany you got your master's?
That's where I got my master's, yes. And the question is, my trajectory, how did I start with botany and end up talking about PFAS? Well, I'm associated with the Institute of Water Research right now for my profession, my job, and also the Department of Fisheries and Wildlife, and I'm also in MSU Extension. And so in Extension, we've been very concerned about all different types of emerging contaminants, not just PFAS, but also harmful algal blooms, which that's related more to my botany background. I did work for my PhD on harmful algal blooms. But in Extension, we formed a committee of Extension educators and researchers that got together and talk about some of the PFAS issues, what's going on with it at Michigan State University and within the state, and I facilitate that team. We've held what's called a speed meeting where we've invited people in to talk about what they're doing, and that's how I was able to tell you some of the research that's going on. And what our extension educators need to know about PFAS so that they, in turn, can answer questions coming in from their counties. So it's just through mainly my job with looking at various issues related to water quality. Mainly I work with inland lakes more so than with groundwater. Some of my colleagues work with groundwater, but that issue is pervasive both in lakes with respect to fish and groundwater. So thank you for that.
Over here.
What role does the EPA play with this topic, if any?
Yeah, the EPA plays a very important role, and they're right now, as I said, all they have is this lifetime health advisory, which is guidelines, non-enforceable and non-regulatory. They may be moving towards something that's enforceable in the near future, but the states depend on EPA to do a lot of that research and to come up with these standards that are used throughout the country. So they do play a big role, and states are looking towards the EPA to come up with what the best concentrations are that should be legally enforceable to, and particularly for wastewater treatment plants. Once these MCLs get into effect, within Michigan, about 2,700 treatment operators will have to abide by those rules if it's an enforceable level. If it's not enforceable, it's just a guideline, and there's not as much, watchdog type activities with that.
It's back here.
In your resume, you talked about algae blooms. Are
Yeah.
those dangerous or toxic?
So there's a group of algae which are called, they used to be called the blue-green algae, and so he asked our blue-green just if algal blooms are harmful or not. Right. So there's different types of algae, and most algae are very good to have in your lake because they provide oxygen for the system, they provide the food source at the base of the food chain, very important to have. But there's a group, they used to be called blue-green algae, and now they're called blue-green bacteria, or the cyanobacteria, and they can produce a toxin that, there's different toxins. The one that is being looked at the most is called microcystin, and it's produced by a group of algae, and we've seen some of the pictures in Lake Erie of these huge blooms in 2014. The Toledo drinking water plant took in a lot of that algal toxin and had to shut down their drinking water plant for the entire city of Toledo. So yes, there are some that are harmful. Different researchers have, and the state have been looking at blooms throughout Michigan. Most inland lakes do not have high levels of blue-green algal blooms. There are some in specific locations, but overall it's very low. Generally, what we say is if you see a lake water and it has something that looks like green paint in it, and it's fairly obvious to the eye, don't swim in it, right? And keep your dogs out of it, because actually there has been one case fairly recently where I think it was like 3 dogs died from drinking water that was high in these toxins that some of the blue-greens can produce.
Yes.
I assume that this research is extremely expensive, like most research is. Is the state, or are the states looking to the EPA to do the research because it is so expensive? And is the federal government doing that research on a continuous basis? And is there some kind of group or committee within the federal government that regulates that research, so that when the states are looking for them to do it, so the states don't have to pay for it? So who's paying for it?
Right. So the question has to do with who's doing the research. Is it the federal government? Is it the state? And who's paying for it? So the EPA does provide grants on PFAS. So researchers throughout the country apply for grants, and there's a good pot of money that's available through EPA, the CDC, and also some other organizations like the Agency for Toxic Substances and Control, Disease Registry, have been doing some research with these populations. I think a good part of the research is being done through the universities. The state, I don't know right now if they have any grant money available, but over time they give out grant money to researchers to do most of the research. So I think it's, and also some companies are doing it as well. But mainly I think the research comes from the university with federal funding from such organizations as CDC, EPA, and then probably some of the bigger private foundations and such like NSF or the National Institute of Health.
Yes.
If
case of the removal of contaminated soil, if I'm a worker and that contaminated soil contained large amounts of PFAS, would I be concerned about the airborne and what I'm breathing while I'm working on a site like that?
So the question is, if he were working on a site to remove contaminated soil, would exposure, if it had a lot of PFAS in it, would he be exposed to it, and is it something to be concerned about? So some PFAS can be in dust, and so if that dust particles come up and you're inhaling them, then yes, that could get into your body more so than if you were touching it. So there's always concern, I think, when you're working at any toxic contamination site, and the proper gear should be used, you know, wearing gloves, wearing face protection for any type of contaminant. So I'd say precautions should always be taken.
Question?
Is there anything that we can do in our day-to-day life to avoid involvement with those kinds of materials, or maybe not purchase certain items?
So the question is there anything we can do in our everyday life to avoid these products and chemicals? And as you saw, these chemicals are used extensively in a huge amount of consumer products, right? Again, and I'll just emphasize, there can be some trace amounts that can get into the body, but just most of these newer replacement chemicals do not have the toxic effects supposedly that some of the longer chains do. But I think it'd be really hard or difficult without some type of federal regulation saying this PFAS chemical should not be used in manufacturing for any type of product where there's food involved with it. I think it would have to come from a federal level for something like that to occur, because as I mentioned, it's just in so many consumer products.
Any final thoughts or questions, comments? We thank our speaker for today.
And thank you. Thank you for all the excellent questions and your attention.